everyone, welcome to another class of statistics for engineers 2. Today we're going to discuss about the linear regression. So this is the second topic on this class. Now let's define first what is linear regression. So by the name itself, linear. So it is a linear approach to modeling the relationship between a scalar response or dependent variable and one or more explanatory variables or independent variables. So it is used to predict the behavior of the given dependent variables. So regression, that is the process of constructing a mathematical model or function that can be used to predict or determine one variable by another variable. So we have here a linear regression equation denoted by this one. So y hat, so this character or this variable is the y hat since it has a small hat here. So this is the predicted values of y, and that is equal to b times x plus a. Okay, so our b, this one, is the slope or the rate of increase or decrease of y hat for each unit increase in x. So as you can see here in the graph, okay, this one, it's a little bit unclear, but we have here plotted points. And this line here, the steepness of this line, that is the slope or the b. So our slope has a formula of its own that's equal to r multiplied by the sample standard deviation of y all over the sample standard deviation of x. So this one, the sample standard deviation, as you can still remember, this is the formula for a sample standard deviation that's equal to square root of the summation of x minus x bar squared all over n minus 1. dr, so this is the what we have discussed on the previous video, okay, the Pearson's correlation. Then another variable that we will consider in the linear regression equation is the a. So a is the y-intercept or the level of y when x is equal to 0. So how to find a? So we have a formula. So a is equal to y bar minus b multiplied by x bar. So y bar is the mean or the average of all the values in y, and x bar is the average or mean of all values in the x. Okay, so we have to remember this formula because this is very important. Okay, this linear regression equation. Let's have an example to apply that linear regression equation. So example number 1, John collected 5 records of his run and the total expenses he spent in his gas. Now he wants to predict how much gas he will spend if he ran 410 miles, 420 miles, and 430 miles. So use the correlation and linear regression to predict the data. Okay, so we will plot the 5 records of his run and the total expenses. So the records of his run in miles, so that is the x, and the total expenses for the gas that he have spent, that is the y. So these are the records. We have 390, 403, 396.5, 383.5, and 321.10. Yan. So we have this data. And first thing that we need to do is to, of course, get the average of all the x. Okay, that is the x bar. So to find the average, just summation of these 5 values. Okay, so 390 plus 403 plus 396.5 plus 383.5 plus 321.10 divided by 5, and that is equal to, ayan, 378.82. Okay, so suggestion, Okay, so for you to understand, so sabayan nyo ulit akong mag-solve. So try to compute for all this data so you can practice how to solve this linear regression equation. So this is just similar on the computation of our first topic, no? Next, so solve for y bar. So same process, just summation, then get the average. So y bar is equal to 31.16. So this is rounded in the nearest hundreds. Okay, 2 decimal places. Okay, all the values here are rounded off in the 2 decimal places. So for our x minus x bar, so miles, so 390 minus the x bar 378.82 we'll have 11.18. Then 403 minus 378.82 we have 24.18, and so on and so forth. Ayan. You can check if these values are correct. Then y minus y bar, so let's consider the values in the y column and the y bar. So y minus y bar, 36.66 minus 31.16. Yan, so we have 5.5. Then let's repeat that on the other values. Yan, 3.55. Yan. Then let's proceed with the squaring of the x minus x bar. So squaring the third column, so we'll have these values. Then squaring of the y minus y bar. Oh, so after you get the square of the x minus x bar, yan, you get the summation for this column. Then for y minus y bar square, ayan, so the square of the fourth column. So these are the values, and then let's get the summation. So 337.13. Then for the last column, the product of these two, so we'll have 61.45. Yan, for the 5 values. And then, again, we need to get the summation of these values, this 5. And that is 1,199.99. Now that we have completed this table, let's proceed with the computation of our Pearson's correlation. So this is just the same formula with the previous topic, the summation of x minus x bar times y minus y bar all over the square root of summation of x minus x bar squared times summation of y minus y bar squared. So just substitute all the values that we got from the tables. We have 1199.19 divided by the square root of 4375.75 times 337.13. So our answer will be equal to 0.9873. So the interpretation of that, if you will refer to the table that I have given on the previous video, that means very high positive correlation. Okay? Because it is very near to 1. No. Then after that, now let's predict the expense for 410 miles, 420 miles, and 430 miles. So we will go back with the linear regression equation. So step number 1, find the standard deviation of x and y using the formula. Okay, so our formula is s equal to the square root of the summation of the square of x minus x bar over n minus 1. So from the table, for x, we have square root of 4,375.75 divided by 5 minus 1. So we'll have the answer as 33.07. Then for y, we have square root of 337.13 over 5 minus 1. That is equal to 9.18. Then after getting the standard deviation of x and y, step number 2, solve for the values of b and A. So for B, that is r times sy over sx, since we have already solved the r a while ago and we now have the standard deviation for x and y. Let's just substitute. So that's equal to 0.9873 times 9.18 over 33.07. So our answer for B is 0.27. Then for A, so y bar minus b times x bar. So from the table, we have already solved the average of y and x. So let's just substitute. That is 31.16 minus 0.27. Yan. We have already solved. Then times 378.82. That's equal to negative 71.12. So to predict the expenses for 410 miles, 420 miles, and 430 miles, let's go back to the linear regression formula. Y hat is equal to bx plus a. So for x equal to 410, let's just substitute all the values that we got. So 0.27 times 410 minus 71.12, so we'll have 39.58. For x is equal to 420, we'll have 42.28. And for x equal to 430, we'll have 44.98. So in conclusion, for 410 miles, there is $39.58 expense. For 420 miles, there is a $42.28 expense. And for 430 miles, there is a $44.98 expense. So from this conclusion, we can say that as the distance he has run or he has traveled increases, the expense for the gas also increases. No? So that relationship is because of the R, or the correlation coefficient, that we have computed a while ago. Okay, so that is 0.9873, right? And it is very high positive correlation. Okay, so if we have very high positive correlation, that is very near to 1. So as the one variable increases, the other variable also increases. Now let's consider the example we have on the previous video. Okay, so this is the table we have. Then we will solve for the linear regression equation. So solving for R, or the Pearson's correlation, so you have summation of x minus x bar times y minus y bar, that is negative 3, all over the square root of the summation of x minus x bar square and the summation of x minus y bar square, that is square root of 28 times 15,183.7. So our R is equal to negative 0.0046, and that is no correlation. Now if we want to predict the sales for days 8, 9, and 10, so we'll have to get the linear regression equation and solve for the y hat. So same procedure. So step 1, find the standard deviation of x and y using the formula. So for x, we have square root of 28 over 7 minus 1, that is 2.16. Then for a y, that is 13,793 over 7 minus 1, that is 50.30. For step 2, solve for the values of b and a. So for b, we have negative 0.0046 times 50.3 over 2.16, that is equal to negative 0.11. And for A, we have 176.57 minus negative 0.11 times 4, that is 177.01. Now we will use these values. So going back to the linear regression equation, so solving for the y hat for days 8, 9, and 10. So let's just substitute all the data that we have obtained. So for x is equal to 8, we have negative 0.11 times 8 plus 177.01. Our y hat is equal to 176.01. 13. Then for x is equal to 9, we have 176.02, and for x equal to 10, we have 175.91. So in this situation, the prediction is not good because the two variables has no correlation. So just like what we have solved a while ago in the Pearson's correlation coefficient, the interpretation is no correlation. That's why in the y hat that we have got is really not good. So you can predict a good data if the two variables has a good or higher relationship, or if the person's correlation coefficient that we have obtained is nearer to 1. Okay? Yan. So that is the linear regression. So just take note of this formula, the linear regression equation. Y hat, that is the predicted values of y, equal to bx plus a, where b is the slope and a is the y-intercept.